Hi class, we're now on chapter 7.7. We're still continuing with constant pressure calorimetry, and this is measuring, pretty much it's easy just to say delta H. Constant calorimetry at constant pressure, this is something we've already talked about, so we're just more elaborating on words and definitions of this stuff, but you by now should be comfortable doing the calculations. Reactions are carried out in aqueous solution at a constant pressure, open to the atmosphere. The calorimeter is often nested in two styrofoam cups, and here are the reaction. We have a reaction and we have a solution. The thought being that whatever the reaction is either absorbing or releasing will go into the solution and vice versa. Now, we have it set up with the negative sign here. Sometimes the negative signs are shown in this way on certain equations because without them, the final value will not have the correct direction, meaning it should have a negative when it doesn't, and so forth. So if it looks a little confusing to you, that is just because when we want the final answer, the answer itself will give the correct value, but it won't give it in the correct direction. And then if we wanted to get the change of enthalpy per mole, we simply have to divide by the number of moles of whatever is being asked. So here is a problem that joins in a lot of stuff, few steps that maybe you guys haven't done, like using density. You should be comfortable using density if it's given to you. A student mixes 50 mils of 1 molar HCl and 50 mils of 1 molar sodium hydroxide. I'm already seeing mistakes I made here. There should be a period, there should be a period, and that should be capital. Just caught it as I'm looking at it. Sodium hydroxide in a coffee cup calorimeter. The temp of the final solution, which this is an acid and a base, it's water, increases to 21.0 degrees Celsius, that should be a Celsius, did not type this up right, to 27.5 degrees Celsius. Calculate the enthalpy change for the reaction in kilojoules per mole for HCl. The total volume is 100 mils and assume water as the final solution, which gives the density and specific heat. So first of all, this is actually an acid and a base. It's a neutralization reaction. It produces water, so it is water. That's why we're using the water information to it. Second thing is it's asking for kilojoules, not joules, kilojoules. So we're gonna have to do a conversion, and the final step, once we figure out the Q value, we're gonna have to get the moles of HCl. So let's get started. First, determine the mass. If density is given to you, that usually means you have to use it. I know that some problems might not. I rarely see problems where they throw density out and you're not supposed to use it. So just keep that in mind. All right, so we have 100 mils total. So we have the solution. In this case, we're not using the actual solid. We're using two solutions. The total mass of the solutions is 50. It's 50 plus 50 is 100 times the density. The mils cancel out. That gives us the mass. So we have 100 grams, and then we do the temperature change, which produces 6.5 degrees Celsius. Now I've pulled out the equation from the other page that we went over, and now we just plug everything in. So that should be only one negative sign. We have, see, I fixed some of these things on this slide. I forgot to do it on the other. Didn't fix that still. This should be one negative sign. 100 grams times the specific heat of water times the temperature change. That gives us 2.7 times 10 to 3. Again, that should be a negative number. I'm just making so many mistakes on this and I don't know why. But I did get it right in the final answer. So the final answer produces negative 2.7 kilojoules. We would not have got that negative because this is an exothermic reaction. There was heat produced released into the surroundings if we didn't have that negative sign. That's why this may not always make sense to you, but in this case, it's being supplied so you can see it. So the question is, when do you use it, when do you not? Most of the problems are they're clear enough that you should be able to understand. Is it an exothermic reaction? Is it an endothermic? And go with that. The fact that this is you guys come in with some understanding, you should understand that an acid and base neutralizes, it produces heat. So you should make sure that when you're working on something, and this is just in general calculations, you should have some idea if your number is too big of a value, too small of a value. If you're working with endothermic, exothermic, you should catch all these things. So in this case, we have the value as negative 2.7 kilojoules. Now we need one more step. The one more step is the moles, and it's asking for the moles of HCl. So we take the molarity and we expand it out, and then we take the volume and multiply it by the molarity, cancel out the liters, and that gives us the moles. Now we divide that, so our change in enthalpy of reaction per mole is negative 54 kilojoules per mole. That's it.